Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. It is Friday, December 12th, 2025. Welcome to the show. Christmas is just around the corner. Hope everybody's caught up on their Christmas shopping. I'm like one of the late guys, so I've been kind of trying to figure out what to get and for who to get it. So this weekend will probably be my online shopping spree. And it's been a busy week. I've actually made a bit of a breakthrough in my battery technology with the electrolyte. So I'm going to have to order some material and make this new electrolyte. And the best part about it is this electrolyte is solid state. So my battery cell technology is going to be completely solid state. There won't be any liquids or anything of the sort in this cell. And it's looking really, really promising. I've looked into a few sources and a few very large companies in China that are actually using the same material to make batteries. So I'm going to give it a try. It's readily available, thank God. And I'm going to order it and start making my solid state electrolyte. So with me out of the way, hopefully Lulu's going to show up. We have a special guest on tonight. We got Elijah Coakley, right? And,
yes, sir.
He's going to share some pretty amazing stuff with us tonight. And as always, we're gonna start off with Philip. We'll get Philip's thing because he's on a roll right now with his free-falling magnet experiments. So I'll let Philip take over the stage here, and then we'll just carry on from there.
All right, thanks, Mike. I'm just going to share my screen. Oop. All right. So last week I made a mistake when I was talking to Dr. Who and questioning Boyd's Bushman findings because I did the free fall experiment all week long, and tonight as well. But tonight I did not compile the statistics yet. But I did the experiment 8 times, like 4 times, times 2, times 5, so 40 times. The experiment. No, I just want to relax a little bit. But I did the experiment 40 times, and here are the compile statistics. The magnet has a lesser acceleration than the steel ball. In each case, for example, if we look at Monday, with the up means that the magnet the polarity is facing the ceiling, so I called it up. Whatever polarity it is. Yeah.
If you get a chance, can you kind of increase the size of that picture? You have a tab up there where you can increase the size of the graph. Yeah, just kind of zoom in on it a little bit. Yeah, that's better.
Yeah. Yeah, we don't see it full though. But that's
yeah, just point with your mouse and then.
Yeah, so you can see the orange curve is the still position versus time. So we see the acceleration, is much greater for the steel ball than the magnet ball, the neodymium magnet. Again, they are the same weight and the same surface area, but the magnet is falling down slower than the steel ball. I mean,
Yeah, and that's the same results that Boyd Bushman got.
yeah, yeah, it's on par with Boyd Bushman and what Dr. Yu bet last week. It's just that last week I did not compile the statistics, but the magnet was launched before the steel ball. So, but if you compile the statistics, the acceleration is lesser than the steel ball in each case, even last week. So last week I did not compile the statistics, but now I did all week long. It took me some 3 hours every night to compile the statistics.
Wow.
And here they are. So that's Monday. And if we flip the current, it's gonna flip the polarity of the magnetic ball. It's gonna face the other way around, and it's the same thing. It's not falling faster. It still falls slower, and you can see the uncertainty is not really overlapping, so it's very distinct. Uh, so in each case, the magnet falls slower every day of the week, every direction. Um,
So it's consistent results you're getting.
exactly, it's consistent with Boyd Bushman finding. Boyd Bushman just did it once, but I did it 40.
Yeah,
Well,
he
he
did.
just did it publicly once. We don't know how many classified times he did it and how far they developed it.
I know
Yeah.
he actually wrote a paper on it in 1996. He actually did publish a paper on it. So I don't know if that's still accessible. It's quite a while ago, right?
So is the magnet faster or slower according to
Slower.
Boyd Bushman?
It's slower.
It's slower.
According to Boyd Bushman, it's slower, and according to me, it's slower as well.
Okay.
So
So it
last
doesn't
week,
contradict. Okay.
yeah, last week I made a mistake. Unfortunately, even if it was a big moment, every time there's big moment, I always screw it up.
Yeah, but we visually saw it fall faster, right?
No, but it was
The other way around.
Dropped sooner.
it started before the other one. You know, it's the ball kind of started before the other one. So it makes a big difference. Just for a fraction of a second, if it starts before the other one, it makes a big difference.
You would figure it would take at least about 10 to 15 feet before the acceleration of the magnet or the one that was not the magnet to accelerate faster than the one that was the magnet. You figure there'd be like a time period where the acceleration has to take place for the one that's a non-magnet to actually accelerate faster than
Yeah,
the magnet.
but I'm talking to somebody on my own WhatsApp group. I think he works for CERN. He's very knowledgeable, and he says he's very interested into this experiment, and he says that it's probably it has to do with the galactic ether or the gravitational framework, whatever you want to call it.
Sure, it's 100% that.
Yeah. So it's the galactic ether. So it depends. Maybe 2 weeks ago, it was different, but it depends on the weeks. It doesn't depend on the time of the day. You know what I mean?
Yeah.
Depends on the.
Now, say you had a magnet that weighed, say, 500 grams, just for sake of argument, right? Now, that has a certain energy flux density that it creates this ball of, a force around the magnet, the flux. Now, if you were able to make a magnet say 1/10 that weight, but 5 times the energy flux field coming around the magnet, the effects would be that much better. It has to do with the mass of the object itself. So if you could keep that object very, very light, but still have the same magnetic properties of, say, like an N52, right? Which, produces a pretty good field around the magnet itself. But if you can get that weight down, so now if you were to do that experiment, your graphic's going to be totally different now. That mass that's, your steel ball is now going to accelerate that much further away than, the magnet would. So I think a weight of the magnet itself will play a part, pay a part in this. So,
well, I mean, it's going to play a role because of the air. There's air friction, but it's really negligible in that case. The surface area, and the weight plays a role in the air friction, and that's why in that case I made sure they had the same weight, the same surface area, but yeah, if sorry, go ahead.
I had a thought there. Joseph Newman did an experiment many, many years ago, probably around 1985. So we're talking a good 45 years ago. Okay. He got a helium balloon. Okay. He only filled it up to the point where it wouldn't lift off the ground. He would have enough helium inside, but it would not lift off the ground. So what he did was he wrapped 30 gauge wire around this balloon. I don't know how many turns, probably a couple hundred turns. Okay. Then he hooked it up to a PWM with high voltage. Guess what happened to it? It lifted in the air.
Yeah, so he created the magnetic field inside the helium.
Inside the helium. And the helium reacted to it, and it rose off the ground. Because when he had it all hooked up, all the wire wrapped around it, the helium balloon's on the ground. It's not off the ground. So it didn't have enough helium to lift itself off the ground. The second he started pumping that high voltage through a PWM through it at high frequency,
did it lift? Did it lift with the wires wrapped around it?
Yep, it did.
Wow, all that weight and it's still lifted up. Well, okay, that's really cool.
Exactly. So he worked out the mathematics on it. So if he had a fairly large balloon, say 20, 30 feet in diameter, with the same concept in mind, he says he could carry some pretty huge, heavy payloads using this kind of idea.
Oh, yeah.
So the magnetic field, I guess, would disturb the helium atom inside the balloon.
The density, I guess.
Inside. Well, no, it would just excite it like heat. When you heat up air, the atoms of the air, the molecules, they start dancing around. They become very active. And that's what creates the lift, right? Hot air balloon. Yeah. Same thing will happen with the helium.
Oh,
because helium
by increasing the energy density. Like yes, it's the same thing.
Exactly. You're right on the money.
The temperature increases the energy. Same thing with magnet. It increases energy.
Right, because it's moving. Because he's using a pulse. He's using pulse width modulation through it.
Yeah, that makes sense.
So all those helium atoms are now active. They're moving around. And because of that, that's what gives it the lift. That's why it's getting off the ground. It's getting buoyancy.
Interesting.
So just an idea.
Yeah. I just want to show you here. It's really cool. What you see is really inevitable that the magnet is falling slower than the steel ball. Look at that. It starts before actually. You can see it's way before it was launched before the steel ball. You can see the red circle is already below the turquoise circle.
What are you using though to like launch them at the same time?
It's electromagnets.
Okay, so then how's that possible?
Well, it's because it needs
Well, he's using.
I mean, it's not perfect. The magnet needs to be at theoretically the magnet needs to be at the exact center of the electromagnet, but the magnet keeps changing position inside, so sometimes it's stuck on the wall of the magnet of the electromagnet and things like that. So that's why it's variable. It's not the same, each time, but it's very close. But it doesn't matter because I compile all the statistics and calculating the acceleration at the end, and I get using that software, the tracker software, and the results are undeniable.
Right. Now, if you were to try, how many feet is it dropping, Philip?
It's 3 meters high.
3 meters. That's what. It's about 15 feet, give or take. Yeah, I would try that experiment with a higher drop, say like 30 feet.
Yeah,
I know Bushman, when he did his experiments, he was dropping it from 3 stories.
Yeah.
And he was getting very consistent results. That's what I remember from one of his last interviews.
Yeah. But anyway, check this out. So you can see the magnet is much below already.
Right.
And look at that. Look.
It just keeps increasing as it goes down. Yeah.
Yeah, and the turquoise is catching up. Look at that. Now they're at the same level.
Right.
And now the turquoise is winning the race.
And that's the one with the magnet.
The turquoise is the steel one.
That's the one the steel one. Sorry.
Yeah.
My bad.
The red one is the magnet, and turquoise is winning the race. So that's pretty obvious, but
you got to squeeze 2 magnets together like Bushman did. 2 opposing and squish them together with a bolt, and then do this experiment again. I think your results will even be more conclusive.
Yeah, what matters is the energy density, So the polarity doesn't seem to matter. Just a little bit. Just a little bit, according to my statistics. Here, there's a little difference between the polarity. Like here, I get 7.8 and 8.3, and the difference here, I get 7.0 and 8.5 meters per second difference. So they're over the uncertainty. So that means these results are not like estimates or anything. They're real, because they're over the uncertainty, which is plus or minus 0.2 meters per second squared. So I cannot be more precise, man. I mean, everything is maxed out. I practiced that experiment 2 months before doing it this week.
Mm-hmm.
I would try that. I would try that friggin' experiment that Joseph Newman did with the helium balloon and wrap the wire around it. That would be really cool to see.
Yeah.
Show that at APEC.
Why don't you just use like a regular ruler and then you just release the ruler and they both fall at the same time and you don't even have to mess with whatever mechanism you have that's offsetting the magnet. You just like put it where the two entrances are, and then just drop it so they naturally will fall both at the same time.
Yeah, talking about the same time, you remind me that the steel ball always has the 9.8 acceleration, or plus minus 0.2 millimeters per second squared. But it's very consistent. The steel ball is always within 9.8. So if I was to use ruler, I would get the same thing, you know. But yeah, so the steel ball is very consistent, and the magnetic
That's
one
great.
is the one that is accelerates slower, lesser.
Right
I
on.
mean,
That's awesome.
and
What I like what you did. Sorry to interrupt. What I like what you did is you did 40 experiments, and to get your 95 percentile confidence interval, or that 5% confidence interval within that, you got to get 33 experiments, and so you exceeded that by 7 additional experiments, and then you're verifying it with your frame rate, right? So even though there's discrepancy in when it starts dropping, you can count the frames, because you not only are you using your visual senses, but you're using the camera to your advantage, because
exactly.
that's counting the time. So I think what you're doing is exactly aligning with Intellect Research LLC, their findings, as well as Boyd Bushman and various others.
Yeah, and yeah, the like Bernie was saying, I just saw his voice earlier saying that they probably did it more than once, but it's all classified, probably.
Oh yeah, for sure.
Yeah.
No doubt.
And the other thing I want to say is, um, I forgot. So
somebody said shout out to Boyd Bushman. Well, unfortunately, Boyd Bushman died quite a few years ago.
yeah, but you know, there's a lot of experiment that has been done, and you know, you can't say which one are real or which one are not. What I did was independent from Bushman. I did the experiment, and it happens Bushman did it, and I'm confirming it. But it's not because Bushman did it that I'm redoing it. You know what I mean? It's completely independent, and it just happens that Bushman already did it. So same thing with energy beaming. I had the idea in 2023 of energy beaming, and it happens that Caltech and Japan already were working on that, and DARPA as well.
You know what? I think it's kind of fair to say at this point, with all the experiments done, like Bushman and yours and many others that did similar experiments, energy density affects the movement of a mass through the ether.
Yeah, exactly.
Right? So we're still proving that the ether is a real thing. It's a very important thing.
But there are multiple layers of ether. You have what you call ether. I call it a gravitational framework, but they're all overlapping. So you have the gravitational framework of the Earth, the Sun, the galaxy. You know, and that's probably what we're detecting right now. The framework of the galaxy, of the ether of the galaxy, because
right.
It seems to be to differ over weeks, not over days or time of day.
Well, think about it. Okay, so you got to say the size of the Earth, right? Okay, we affect the energy density going through the ether through space. So there's a ratio of what our mass is on the planet. Now, say you go to the moon. The moon is 1/4 the size of the Earth. So naturally, if you go onto the moon, our mass is going to be basically 1/4 of what it is on the moon compared to Earth.
Yeah.
Right? Because the size of the mass that you're on affects the energy density through the ether, which affects our weight on the planet, how much weight we exert on the planet.
Yeah.
So it makes sense.
That's what the force. That's what the force is. It's just the energy density differential. That's all it is.
Yeah.
And energy can be can be gravito-electric, gravito-magnetic, electric or magnetic, or both, which is light. So you can use light to light differential to create a force.
Yeah, but it would take an enormous amount of light to actually.
Yeah, but not astronomical, not astronomically. A huge amount, yes, but not astronomical amount.
But say like a UFO, if that's basically the way they're doing it, is by increasing the energy density around the craft.
Exactly.
Right? So the more dense it is, the more or less of effect of its mass in that median.
So that's why I'm proposing the force field to Lockheed Martin and all these technologies, because
maybe
that's what it is.
It sounds like it. It sounds like that's the right direction, and that's why they're kind of shutting people down, because they might have already knew this because of Bushman's experiments back in '96, and
maybe
after that it went totally black. And anybody else who came up with the idea after that, they didn't want any involvement because they don't want to say, yeah, you're on the right track, but we're really doing it in a black project right now. We just don't want to tell you. Right? So
yeah, but the problem is I applied for Northrop Grumman as well. So if they reject me, then okay, so be it. I'll work with Northrop Grumman.
Mm-hmm.
You know what I mean?
Exactly.
So that's how you negotiate these days.
Yeah, exactly. So we have a new guest on tonight. We have Elijah Coakley on with us tonight. He's got a YouTube channel as well. We're gonna let him do his thing and share some stuff with us tonight. Maybe just kind of give a brief oversight on your history and what you've been doing on YouTube, and your interests and how long you've been at this type of stuff that we're doing.
Yeah. So my name is Elijah Coakley, and my channel name is Elijah Tack. And basically, I've been into science ever since I was a kid. I got a perfect science score and math score on my STAR test when I was in like 4th grade, and the teachers thought I was cheating and stuff. So I got bumped up a grade, and then because of that, I just figured I should lean into my skill sets of what I was adept at and my interests. And I've always been interested in light. Light has fascinated me. And I've always had a curiosity for the universe. And I wanted to be a benefactor to society. And because of my unique experiences as a kid with what some would consider paranormal, it kind of drove me to want to see a change in society. So I went to Oregon State University, got a Bachelor of Science in Mechanical Engineering, went into gas upgrading for a little bit, done multiple internships. I worked in Allergeny Technologies for a little bit, and Leatherman Knife Company in manufacturing. And I've done a lot of different work experience, and I have a lot to offer. But like material science and understanding the nature of the universe and how that connects to God is kind of my passion, because I feel like the universe has like this perfect bookkeeping, and the ether and the information being there and our ability to tap it basically just points to that God loves us, in my opinion, and how he has structured everything to our advantage if we just tune into it.
Right on. Awesome. I guess, because I've kind of had similar things happen, when I'm doing my experiments, just kind of like stuff that's unexplained. We'll say that. And
yeah, me too.
Not that it was just a one-off. It's happened several times. And I've talked about it a few times on the show and other.
You and the orbs.
Yeah, that and yeah.
Did they respond to your thoughts?
Yes. Yeah.
Yes, they do. Me too. Especially the
Yeah.
red ones.
Yeah. Most of the ones I've had were either like distorted black images, or they were a defined colored image, like a dark blue. And sometimes they would be like
Hmm.
in groups, more than one. I've had as much as 3 or 4 of them in a group, and they would always be, for some reason, I don't know why, in a triangular formation. Always in a triangular formation. So I don't know if that's relevant or not, but I've had other weird stuff happen too. So
No, it's definitely relevant. I've had UFO experiences throughout my whole life, and when I do certain experiments, they'll like show up and stuff. And but yeah, that's kind of besides the point. The universe is definitely interesting, and I know aliens are real and whatnot, but I kind of wanted to start with material science and turn my screen around here because there's no one special material, right? But there is like some materials that can give insight. I'm trying to change this. I'm sorry. I'm like tapping the wrong button here because it's such a small button.
You want to do a screen share? You can do that too.
I would, but I'm on my phone, so I just kind of wanted to give attention to the HCP crystal structure because these hexagonal planes create a torsion field, and they create 3 unique slip systems. And so 3 gets composed into 9, 3, 6, 9, which is the fractal geometry. And then basically you have 6 slip systems, which are the 6 nodal planes of the time crystal. So if I were to show you this FCC, you can see you can draw different planes. And if you were to draw an X on each face and erase the cube, you would get a Merkaba generator. And that collapse is what makes the swastika. So that's kind of what I wanted to introduce with. And the reason why is because we've been talking a lot about like electrons and like protons and what they are, but really all it is like this orbital function, the s orbital, where the quantization value is really just the max probability of a specific orbital shell. So it doesn't have to lie there. The whole quantum thing, it is really just a way to mislead people from the truth, because it can exist within anywhere in here. It's just not very probable to be here or here. And I wanted to give attention to that because that idea is very important in the plasmoid unification model, right? So we see that there is basically a spin moment in reductionist model that has angular momentum, torque, and you can see the wheel within the wheel within the wheel start to form from these charges. And so you have basically a B field that arises from that, as well as a linear velocity. And that's kind of what the electron is. And the electron is really an electromagnetic field confinement that curls. And that's why it wants to form Cooper pairs, because it'll curl one way and it will want an equal counter curl, like the Mobius strip. On one side, it will invert, and the other side, it has to invert likewise. And so I got a big stack of books here, chemistry and all sorts of things. I don't want to get like too into the weeds, so I like made a bunch of bookmarks for you guys so we can like kind of like go into this. So like going back to the basics, because this is important. The basics are like fundamental, right? What is even a volt? A volt is like your energy per unit charge, right? So your joules per coulomb. So it's this ratio of like your energy density. And that goes directly back to what we were just talking about with the magnets falling, because we were talking about the flux density, right? And when we look at the amp, it's the flow of current, which is the number of coulombs per second. And so you can see it's kind of in this inverse ratio in relation to the volt, but instead of the ratio with respect to energy, it's actually with respect to seconds. And so it's coupled to the frequency, right? Because frequency is cycles over time, essentially. And so the amp is coupled to the frequency. So when we go high frequency, we're essentially saying, okay, we're going to minimize our current draw until we get to the load, and then it collapses that magnetic field of the standing non-Hertzian wave, and then it becomes basically this current. And what I found fascinating from my experiments is that basically electricity and nuclear physics is inseparable, and light and sound is inseparable, and that the Walter Russell scale is legitimate science. And I was able to climb to chlorine in my water cells not once, but twice, making it repeatable. And I removed the salt and redid the solution in my cell to make sure that that's not what was being caused. And so what I realized is that it's actually like this beta nuclear interaction. So you can actually have what's known as beta decay. And for example, you can go beta positive. So what that means is you can make light form matter, just like the Bethe-Hilter process, but instead of with the negative charge of the electron pair, it could be with the proton. But likewise, you could form, you could take that extra neutron, sorry, I misspoke. You could take that extra neutron, do beta minus decay, so the neutron gets released, and you emit electron pairs. And so you can see...
Elijah, I'm just going to scoot up for a quick smoke. Just carry on. Philip and Lulu is going to be here with you. I'll be right back.
No problem.
Okay.
But this is straight from my studies in college. It was right there all along. I just didn't connect it to water cell technology until my D-Phi oscillator build. So you can see carbon to nitrogen with electrons. And so I was using activated carbon in my water cells, and I was releasing, initially, I didn't smell any gases. It seemed like it was hydrogen. I tried to light it on fire, but it didn't light at all. So it was either nitrogen or helium or something like that. I didn't have a spectrometer, but it was definitely not hydrogen being released. So that was a good indicator that I was on the right track of the Russell scale. And the D-Phi oscillator is really interesting of my build, because what I learned, I'm going to flip my camera back around. What I learned with the D-Phi oscillator build is that Oliver Heaviside was completely wrong.
Can't see anything.
Yeah, it's like I said, I'm having a hard time pressing the buttons here because it's so small. All right, now you can see me. So Oliver Heaviside was wrong in the sense that the cross product of two charges is not zero. It's actually a sinusoidal function, and that's driven by the non-Hertzian wave, the scalar wave. And what I learned was that you could pay for your voltage, just like Tom Bearden said. You could have your switch completely off. I had a mechanical switch to my Bendini motor that ran to my toroidal magnet that went to my water cells and whatnot. And that ran a DC injection loop into a microinverter. But the point is that the energy flowed across the switch even with it off. And that basically confirmed that if you have real voltage that you pay for from somewhere in the environment, and you combine it with displacement current density, which is your switching of your dipole, of your dielectric field, that you get real power transmission in cold plasma. And I also learned that the transistor is an optical switch. Not only is it an optical switch, but it's an over unity device when it runs cold. And we've been talking about this, but now I got a textbook example to show you. And you can look at my YouTube channel if you want to see videos of physical proof as well.
Can you post your link of the YouTube channel?
Yeah, I can after I'm done talking here.
Yeah.
It's kind of difficult to do all this at once. Actually, I'm going to go straight to the point. I was going to give you guys all this introduction so you guys can understand, but I want to get to the point because this is cool stuff. And I've been talking about Dr. Bratton a lot. He's a Nobel Prize winner, the most important Nobel Prize winner of all of history. And this is why. The MOSFET, the NPN junction or the PNP junction. So in this case, you have a type P material. All that means is there's holes in the material. Type N means that you have extra electrons. So basically, you have a difference in voltage on a material level between these things. And they act like nonlinear oscillators, like a spring mass function. And that's important because the holes times the extra electrons is no longer a constant in a closed system. It's an open system with the environment, and K becomes nonlinear, just like a spring mass function, like a differential equation. And so what this shows is if you have a battery here, positive, negative, and this is your input voltage, right? And you forward bias a PNP, for example, and you have this load, let's say, and your output voltage here is higher than your input voltage. So right in the textbook, we see over unity in circuitry with material science is right there. And I just wanted to make that very clear. And we can look at basically these different graphs of what's going on with current versus voltage in these types of systems of PN rectifying junctions, which is basically like an LED, which is an NP junction, but a PN junction would be a reverse bias LED. And if you get a drift velocity with a displacement current density with a little bit of heaviside component, even from your body with Feynman's electrostatic potential, you can light that LED just by touching one side and touching it to the ground like wet ground. And you can even reverse it, and sometimes it does it too, depending on how your energy is flowing, right? But we can see that we get these big positive spikes of current flowing, and the negative current is pretty small. Now, how you get a big avalanche of current is you reverse bias, like a tunnel diode or something like this, but just missing that part. And if you hit the breakdown voltage, what can happen is it avalanches a bunch of electrons. And why that's really cool is because of something called ferroelectrics. So ferroelectric is the material science version of what Tom Bearden calls asymmetrical regauging. And so a ferroelectric exhibits spontaneous polarization. And I bring this up because we're just talking about dropping magnets, and the consequence of gravity is an aspect of the polarization and the spin of the matter and how the ether drag flows through it. So if you have a river flowing and you have a rock inside that river, well, guess what? The river will want to counterflow and flow uphill around the rock. And so the ether does the same thing, but what's different about ferroelectrics is they're oscillating in an asymmetrical way already. And just like how the oxygen ion is magnetic. It's magnetic because of that asymmetry. And that's why they use barium titanates in radio stuff, because it actually acts like as an operational amplifier in certain ways. And so I want to give note to these chemicals because these are very important in alchemy, because the phosphate group, phosphate 40 specifically, can make antimatter, specifically every 75 seconds under normal gravitational field conditions. And so zirconium wire, for example, is used in your magnetic resonance imaging machine with the wire. And Rochelle salt is in the Bendini alum salt battery, right? And you can use potassium niobate, basically niobium batteries, on the 1993 9-volt military scalar electromagnetic D battery, which John Hutchinson shows. And so I'm basically pointing to all these things. The reason why is because they operate at basically a high temperature. So ferroelectrics have extremely high dielectric constants. So the ether is a dielectric at relatively low applied field frequencies. So it works basically within our regime of interaction because we're really big. And so, for example, at room temperature, epsilon sub R for barium titanate may be as high as 5,000. So this is basically epsilon, I told you earlier, the displacement current density is equal to epsilon naught times negative dE dt. Well, this is basically a constant similar to that, but it's based in sub R, denoting that it's based on material and the thermal vibration, like you said, with helium, which actually goes into the Sussy inversion model by Dr. Corinne Johnson, because that actually tells us how the Big Bang actually happened, which aligns with the Walter-Russell scale and true plasma harmonics of the plasmoid unification model. Because these reductionist models, while they are valuable, they are incomplete. And so by looking at these materials, we start to see a more complete picture of what's really going on. And you don't need special materials to make special things happen, but it sure does help. And it sure does hint to some truths of the universe. And I thought that was really cool that it was right here in this textbook for everyone to see.
Yeah, that's awesome.
And this is the other thing I want to say. I was going to go through all of these pages, but I think it's better to focus on a couple things that are more important, because I don't want to overwhelm people, because that was a lot. So Marcus theory, I also figured out, is not just theory, it's applied science. And it's right here in this textbook. So you can have these basically, this is like an energy band of your atom. This is like what they call your quantization level of energy, right? So you can see when your interatomic separation goes this way really far, it's always quantized. It's quantized, quantized, quantized. They brainwash us, right, in all the movies and everything. What they don't want you to know with high frequency, when you start touching the atom with X-rays and gamma rays and things, is that you're going into the equilibrium interatomic spacing at such a level that these energy band gaps start overlapping. And so it starts being a multi-frequency broadband amplifier with high-frequency light. And so if you have basically two plates, right, the light, if it's longer than the distance between these two fingers, it just flows right through. And if the light is equal to or smaller than the distance between my two fingers, it gets basically hit. It touches. And so that's like your base 2 touch. And to flow right through with light larger than that band gap is like your base 3 not touch. And so that's like the photon and the phonon interaction with the matter. And so essentially, at some point, they start converging. And you can see that these individual allowed energy states are not just one electron energy state, but many when this interatomic separation is small. And so if you were to look at Bruce C's alt channel, Bruce Swartz is dead, rest in peace. But if you look at his channel, you'll see the passion line harmonic that is generated from the craft, the flying craft. And it's just like the X-ray refraction through a material, forms like 8 lines, and that actually overlays the neutrino refraction. If you look into the AT&T Technology Archives channel, Matter and Waves videos, as well as the Dr. Bratton lecture. But let's take a step back, because what does all that matter? It doesn't even matter if we know these things if we can't apply it to do real work. Excuse me. So how do we get more out of this? We look at the ideal operational amplifier. So ideally, you'd want to make the current go to infinity, and you're in order to do that, basically, we want to use maybe some negative feedback here. And this is the signal, it's the symbol for operational amplifier. So VP, VN, and then V naught. So positive, negative, and then your output, let's say. So positive, negative current. And so the negative will want to go to the positive more than the positive will want to go to the negative. And so you can kind of, like shorting the base to the emitter of a transistor is basically the same as being like, okay, I'm going to take this negative to here through a load, and I want that current to be basically going to infinity. Well, how would you do that? Because you don't want current in transmission, you want voltage. Well, you only want the current at the load. Basically, what you're going to do is you're going to collapse the non-Hertzian wave, the standing wave, the scalar electromagnetic wave, and it's going to be like slow lightning, and it's going to be like a collapse of the magnetic component, like the Merkaba generator. And excuse me again, you have to be very careful in how you regulate that. And that's why so many scientists and experimenters use the incandescent bulb with the filament in there, because it bleeds off the scalar energy well. So that's what I was using in my DC injector loop, so that I didn't just blow everything up. All of my capacitors would have runaway and blow up if I didn't do that. And so you want your load resistor to equal your resistor RTH here, where, so this is like your RTH, and this is like your, maybe your load out here that it's going to. And so you're matching impedance is what I'm saying. And so it creates phase conjugate waves. That's really what's happening. But you can follow these equations and whatever, but that's kind of besides the point. It's not too big of a deal. And so in thermodynamics, right, you basically, you have open systems or closed systems. And what I want everyone to focus on are open systems. And instead of drawing these tiny black boxes of your Gaussian surface, expand your mind. Consider it coupling with the environment, because the capacitance of the entire room will couple with it. And you can make your whole room magnetically refrigerated. I did that with my 5-day runtime with one of my motors. And so that brings us to ward force. So ward force is to consume or generate current in a magnetic motor. So the way that we're currently doing it is you loop a generator, like a hydro generator, And the unfortunate thing with that is the current goes into the generator when you're trying to use it again to where it's magnetically braking. Instead of doing that, you just have a line positive, a line negative. Now you have a pure dipole across that, and you're utilizing the heavy side component with the displacement current density in the cold plasma regime. Now all you have to do is set your drift velocity as you desire with the impulse. And so I just want to introduce ward force a little bit to people because it's kind of something that is not taught in school at all. And it's defined as the force part of the magnetic field, which has been isolated from the poles. Showing respect to the theory of relativity, I do show that equal and opposites exist, i.e. the dipole. Take the source out of a motor or generator, turn it 90 degrees, then put it back in. Now we're going into the plasmoid unification model of what Malcolm Bendall talks about. Now by changing speed only and when taking current, torque will either be generated or consumed because both poles are used, not one pole to the other. Twice the potential energy is available. Now that another part of the magnetic field that is not a pole at all is being used, then twice again, the potential energy is available. It looks like 4 times the potential energy is available for use that has not been utilized before now. And so you can see, wow, he built something that looks similar to what I built. I kind of bought this after I figured a lot of those things out, but I was like pleasantly surprised that this is like a motionless electromagnetic generator, and that's pretty cool to see. So
Kind of
yeah,
like Tom Bearden's Meg device, right?
Yeah, Tom Bearden's waterfall. And this goes into my own personal notes. So this is my little notebook, some peg cell stuff. You can see Casimir force here. And so this is 0-point energy introduction. So E is your energy. Energy of your 0 point is equal to h bar times W over 2, where W is your angular frequency of the oscillator. And that's important because everything is oscillating all the time. If you take a charge, you place it in a uniform magnetic field, which you can treat as uniform on Earth's surface, Earth's magnetic field, it oscillates, right? Now we're going into Sheila's research. And so h bar equals h over 2 pi. And I'm here to tell you that there's no limit to frequency. And that Planck's constant, you can go beyond that. And I can't articulate why, but I that's what I believe. And so you can treat your energy of your 0 point equal to your minimal observable scale, h times W over 4 pi. Oh, 4 times the force, just like we talked about in ward force. Okay, so it's all about waves, right? So if you pluck a guitar string in space and it's open-ended and they come together like this, but if you fix one end, it kind of behaves like this. And so this kind of acts like altermagnetic one-wire feedback. It cancels superposition, whereas this acts like a looped wire stacked superposition. So everyone teaches you this. I want to teach you this, because this allows you to have superposition that cancels. Meanwhile, you have real energy transmission because you place a real charge in there and it'll still move. In fact, the charges would move away from the center point in this instance.
Yeah, so you're talking about the some sort of destructive interference?
Yeah, so they tell you to cancel or get rid of the back EMF in school all the time because they teach you this concept of basically a looped wire. But if we were to consider only one end fixed, like a one-wire circuit, now you almost have an altermagnetic field that's generated, one-wire feedback, and it will cancel superposition at one point. But just because it does that, and just because maybe you observe zero energy at a single point, doesn't mean that the energy isn't flowing. And if you place a charge in there, you can get it to move and you can get real work. Like I've been saying with the displacement current density combined with drift velocity and the heaviside component. And that's where the genius of the PEG cell battery charger by Joel Legace comes in. And so you can actually tap your mains of like your wall and draw basically no current and utilize the flux of the switching of the voltage to get real power to charge your battery banks to run microinverters or phase locking or whatever you want, because the meter doesn't read the voltage. And so the power companies don't like that, but it's true.
Yeah. See, it's kind of how I use my Renegade. I'm doing the same thing with the battery. I'm just stealing the potential, not the current, off the battery. And it kind of the same idea. It's just my source is a battery, right? That's why my batteries, I could use dead batteries and still get have decent performance out of it, because I'm just robbing the potential off it, not the current.
Right? Yeah, you know what's up. So what I wanted to conceptualize here is that if you take the limit of, let's say, frequency going to infinity, basically you're getting a superconducting circuit. And that's important because now you have really low losses all the way up until this point where you want to displace the ions. Well, how do you displace the ions? Oh, look at this, 1 kilovolt gas discharge. This is a broadband amplifier, and the spark gap makes this heavy impulse through these coils, and you can isolate the secondary from the primary. In this configuration, it's a little more complicated with the way it's looping, but in the most simple sense, what you can do is instead of looping your secondary, you keep it one wire, and on one side of your secondary winding, you have branching diodes where one goes forward and one goes backwards. And it's that simple because that'll create a relative ground that you can tap off without canceling the dipole on your primary. And now I'm going to loop all the way back to material science of Garrett Modell's research, because that concept that I just said about the transformer directly applies to material science. And what zero point energy researcher Garrett Modell has been doing. And so this is just an example. You can take silicon dioxide, nickel, aluminum, Al2O3, so aluminum oxide. And by the way, that's the HCP structure, which creates the imploding light refraction of the hourglass. And the hourglass inverts into the wheel within the wheel within the wheel. Now you got your palladium, and then you got another layer of your dielectric silicon dioxide, and then you have an aluminum mirror. And this is an asymmetrical cavity where this is a big gap right here, and maybe this is smaller, but the point is you have a difference in electron volts here, you have no galvanic action, and yet these electrons will teleport from the nickel to the palladium, and you have a difference in voltage that you can tap continuously off the asymmetric light pressure. And basically it's like the Bethe-Hilter process with some tunneling through the microwaves, because if you think about it, what do they make the magnetron sleeve out of? Either barium titanate or this Al2O3 structure. And so you're getting this asymmetrical radiation effect with the Casimir cavity that creates a net upward flow of the negative charge or the electrons. And
how about the quantum tunneling effect?
Yeah, so how you get that to work is in order to tunnel your charge, you need higher frequency because your tunneling probability goes up with higher frequency. The tunneling probability goes up with higher voltage. So if you have a higher difference in electron volts, your tunneling probability goes up. And likewise with the higher frequency, if you have a smaller band gap or smaller separation distance between these two metals, and you can use different things, they just need to be difference in electron volts. That tunneling probability goes to 100% basically as you increase those factors by a decent amount, because it, like I said, it acts like a spring mass function, like a differential equation, where k equals k prime, and then that's dependent on like an exponential function from there on. So we can see this HCP structure here, and you can almost see the torsion fields that can come out of it, which is why Grebennikov's work with the scarab beetle and Alexei's graviflyer is working on a material science level, because they have this same sort of structure going on that's allowing this process to go on. And when that process goes on, now you have electrostatic charge assisted lifting. And so that's the beginning of modulating your local surface gravity to fly. And so that's how the scarab beetle actually can fly, with the upper wing. And here's your time crystal of your 6 nodal planes. And so that's the Merkaba generator. I drew this before you guys even did the Merkaba thing, which I thought was amazing that it was the same thing. That blew my mind. And I found this through Perry Weiss and the unconventional D wave to the G wave. And this is also Thomas Jungsworth's work. And so what's really interesting about this is altermagnetism. The fourth type of magnetism is an alter spin polarization. So your diagonalized rows are all aligning in their right or left-handedness, if you will. And so if you apply an electrical bias in this altermagnetic fields, what happens is all the upspin electrons aggregate and all the downspin electrons aggregate. So you'll get downspin going one way to the left, and you'll get upspin going to the right. And so now your Cooper pairs are like building this potential energy. And that's the beauty of rutiles in John Bendini's work. That's why he's fascinated with them, because it's really an optical switch that is working in this altermagnetic alter spin polarization state, which is allowing basically just like how light refracts through matter and forms those diagonal rows, just like how you drive down the road and look at an orchard, right? Well, you see the different rows, and that's the same way the light will want to travel in a material. And it'll travel in the path of least resistance. And what that does actually is it allows for a Bose-Einstein condensate to form with the chirality of all the electrons moving together, because what this really means through Dr. Bratton's work is that the sign of the electron is entangled to the sign of the light, and the light is propagating everywhere all the time, every when, because everything has temperature above absolute zero, and charge is an intrinsic property of matter. So charges oscillating all the time are driving this process, and they're waiting to be tapped by you. This is our 0-point energy from the universe waiting to be tapped. You want to tune into protium? You can do it. You want to tune in to the most abundant material in Earth's crust, silicon dioxide? You can do it. 70% of Earth's crust is silicon dioxide. And that's a transducer. And likewise, that goes into those ferroelectrics of your hematite pulse, which goes into your blood alchemy of how you actually breathe. It's an alpha polymorph, which basically is operating in your terahertz energy and picosecond time pulses, so ultra high frequency, just like I said we wanted. And it's basically forming these hexagons of oxygen. And I told you the oxygen ions are magnetic. It's a ferroelectric high epsilon sub R constant. And that is making holes tunnel in the ether space. It is polarizing the vacuum. That is really what I'm saying. It is creating a time crystal of polarization, and that is energy that can be harnessed. how do we harness that? Well, your transient fields, they can be harnessed in, let's say, these semiconductors that are doped, M times P. Okay, well that's constant in a linear regime, but let's say we wanted to get extra electrons from the environment. Well, we're going to make copper wire, and we're going to insulate it. And we know oxygen's in the environment. So we know oxygen is going to diffuse through that insulator, and it's going to form copper oxide, and it's going to form a layer of type P semiconductor. And the band gap of copper oxide is 2.4 electron volts, which is the same band gap of the peak emission spectrum of our sun. So we're literally having our entire energy grid couple optically through the insulator like a type P semiconductor because of the type of materials we use with our wires. So everyone should be paying very little for their electricity because we're using a cyclotron resonance all the time and no one is even aware of it. And by the way, what that really means is the mass of your electron goes down with altermagnetism. And that is directly related to what you guys were talking about with the magnetic experiment being dropped. So yeah, here's your square the circle concept, right, of your light cube. E equals mc squared. Well, if c equals wavelength times frequency, right, then really this just means m wavelength squared frequency squared. So it's like a cube, and the cube goes back to the time crystal, which can be formed through different geometries. Like maybe you want 3 or 4 stainless steel nested hemispheres like this with an angle of 52.84 degrees to create your laminar flow counter vortex, and boom, you got a Vajra. You got a thunderstorm generator that transmutes elements. And it works because of this. And that's why Dr. Bratton is the most important Nobel winner of all time. You take that input energy, like your Gibbs free energy, a little heat and vibration, and boom, you got free electron pairs through beta nuclear interactions in water. And that's where the genius of Stanley Meyer comes in. He didn't even know it. Yeah, there's more I could go into. Here's your copper bowl alum salt battery by John Bendini, which is basically acting like a 3-dimensional diode.
Yeah,
just like how Garrett Modell's work was.
Corpus copper, he calls it.
Yes, sir.
CuO. He bathes it in borax, and the borax creates the corpus copper.
Yeah, so here's how you make it. You heat the outside with a hot plate till silver black, dip in borax solution quickly and rinse it. Use alum pickling compound and form the crystal with alum. You mix the alum in distilled water in a small amount of water. You put the paper bowl on the inside or coffee filter. Put magnesium in the base of the bowl, making solid contact with that bowl, and then it grows a crystal. And as that crystal grows, it emits energy. And you want to know the craziest thing? Here, I'm going to flip around my camera. The craziest thing is that when I did my DeFi oscillator build, there was crystals coming out of my water cell, out of the top of it, and they'd start white and they'd turn yellow. And I put them on a microscope, and they were changing shape over the span of months. And not only that, if I put the crystals like anywhere really, on a plastic, on granite, on like anything, it formed this film like fog around it that decreased with the like how light intensity decreases, like in that square factor with the radius. And I believe that those water cells were absolutely climbing the Walter Russell scale, because it smelled like cleaning solution multiple times, like chlorine gas. It smelled like other things too on certain days. And I was able to get my LEDs to run constantly off of them. And now I know Walter Russell is the real deal. And that's like one of the biggest implications of this, because now the door is being opened into the water fuel injector technology. Because everything I've told you
I get the
is
similar effects. I'm getting the similar effects. Instead of using a copper cup, I'm using a carbon graphite container, right?
So that was like forming on the sacrificial anode, because I had activated carbon, and it was like dissolving and then recombining. And I made a video, my like last live stream where I took it apart. I show that and one of my sacrificial anodes actually made a spiral structure of green copper like solution, and then the black like carbon was spiraling with it, and it formed like a quadrature structure. So you had like these bands of like green and black spiraling down my central rod.
Right. Cool. Well, you've definitely done your homework. A lot of
yeah. There was a smart stuff. But keep in mind that from my perspective, quantum mechanics is based on probabilities, but I don't believe in that, because I think everything can be predicted exactly. The only reason they're using probabilities is because of the double slit experiment they couldn't explain, but it can be easily explained with the phase of the photon or the electron that get diverted randomly. Well, I mean, not randomly, but based on the phase of the electron or the photon. That's the first thing. Second thing, the photon, like the light speed of the photon, c, is not a constant that comes out of nowhere. That comes out of nowhere. It's really the result of the energy. When you have the annihilation process, you have the energy of the electron and the positron that creates two photons. So you have these two particles that creates two other particles. I made the calculation already, and the resulting energy is converted into kinetic energy. So C is just a kinetic energy. It's not a universal constant that comes out of nowhere.
Yeah, I agree. Even Eric Dollard, one of the best electrical engineers, he refers the speed of light as an arbitrary constant. It's not consistent. It varies. But regular mainstream science, they want to use the speed of light as a constant, and it isn't. So
exactly,
how can you do that if it is not a constant? And they're saying, "Oh, it is a constant." Well, it's not.
Yeah.
So
I agree with you guys, by the way, and my findings agree with you too, because the speed of light is like the ripple of the ether from the non-Hertzian wave, like a leaf is on the surface and you drop the rock in the water, and the leaf is like the light photon propagation, right, along the ripple, right? That's the part we observe as real. But in reality, that impulse of the rock dropping and that pressure wave is faster than that ripple. And all the water molecules move vertically. They don't move out, right? And it's the same thing with the ether in three dimensionals. Like,
Right. Like going back to Heaviside really quick, Eric Dollard said when it comes to the Heaviside component or the electrostatic field, it's pi over 2 to the speed of light. So we're talking at a potential that's double the speed of light. So right there, that's like totally incredible right there. that there's something that could actually exceed C.
Yeah, but
Right?
the other thing is the quantum tunneling. You were talking about the quantum tunneling. That's why I was talking about C, because quantum tunneling is not like a mini wormhole or anything like that. It's just the kinetic energy, the frequency is being converted into kinetic energy back and forth. You know what I mean? So
Mhm.
yeah, you have a photon with a frequency. The frequency is destructed somehow, but so it loses energy. But the energy is converted into kinetic energy, so that's why it travels faster than C. And then it pops out back into frequency, which is normal energy, and the slows down. So it's just a conversion into kinetic energy. You know what I mean?
Yeah, and that explains hysteresis of the ether in the S curve.
Right. Good point.
Yeah.
I
And
thought like the frequency would be smaller than the lattice structure of whatever it's going through, so it just, like it goes through because of like the oscillation. You know, you have to also know what it, like quantum tunneling, what is the medium that it's going through. That also is very important. It has lattice structure.
Well, the fact is, to quantum tunneling, there's no means of really any electrical energy needed for it to go from point A to point B. It makes it through, irregardless. Like you're saying, you got the energy potential difference between A and B, but if they're close
Yeah.
enough, somehow that charge is going to make its way through with no means
Right.
of adding power to it or not. You don't need to. It makes its way through. That's why the phenomena is so incredible, because you can have a standing charge there, and that's it. That's all you need. It will make its
Yeah.
way through the median.
All you need is that volts, which is right that joules per coulomb, and the coulombs already exist because charges are everywhere because matter is everywhere. And so
yeah,
you, like you're saying, you just increase that flux density that you pay for from somewhere in the environment, whether it's Feynman's or the ionosphere or a battery or
And that's an
whatever.
open
But
system. And that's an open system. It's taking it from the environment, right?
mhm,
yeah. And I also forgot saying that a photon, the mainstream keeps saying a photon has no mass, blah blah blah. It's all bullshit, because E equals mc squared. I mean, if you have energy, you must have mass. It's the same thing. So
right.
that's why I'm saying that photon can have a kinetic energy, because it has mass, which is energy. Same thing. So they keep saying
Yeah.
that a photon has no mass because of the special relativity will all fall apart if you say that photon has mass. So but I mean, E equals mc squared. So if you have energy, then you have a mass equivalent.
Well, it
So
has no
that's the other
rest
thing.
mass, right? Because it's not at
Yeah,
rest, because it's nonsense to say that it is at rest, because what makes light light is that it's not at rest because it's the ripple of the ether driven by the scalar wave. So, of course, it has no rest mass. It's the other part of the equation that's driving it, right?
Yeah, like
well,
Steinmetz had a very good way of showing it in his Waves and Impulses book. It shows a cross section of two hydrolines, and it shows the waves, the scalar wave, the electromagnetic wave going around. And what happens is when you start pumping a huge amount of power through it, everybody would think, because of the magnetic field, it would pull its way in. In actual fact, it pushes its way out, because the field density in between those two power lines is increasing and increasing. And what happens is, when you push enough power through that space, it's like you can't fill the bottle with any more water. It's going to overflow. And that's when you get the runaway. That's why you'll get the lightning bolt. It'll actually breach the protective coating on the wires, and you get a runaway because the energy density with the ether and the magnetic field and the scalar potentials, you can't push anything closer together anymore. There's no more room. So the only way what's going to happen is well, number one, you'll get hysteresis, and number two, you're going to get a runaway, which means that protective coating on your wires is now going to fail. So,
Yep.
I don't know, Elijah, if you could add to that.
Yeah, you're absolutely right. And my experiments of shorting wires confirm the forces you feel, as well as the vaporization of the insulation at these nodal points of interference. And what's really cool about what you said is the runaway effect, because way back when, the reason why they got rid of all the clear insulators in our energy grid is because they were coupling with the environment like an AM radio too much. And it was acting like a broadband amplifier, coupling the negative like I was just showing you with the op amp, because really it's starting to optically interface with the sun, the telluric currents, and the ground itself. And as I just showed you, when you take an NP junction, you reverse bias it, and you hit that breakdown voltage, just like you were saying with that insulator, which is a dielectric hitting that breakdown voltage, that's reverse bias, it avalanches. And that avalanche is 0 point energy.
Yeah, okay. Wow. Never looked at that before. Cool. I'll have to look into that.
And you were talking about the going faster than the frequency, faster than the Planck constant. Did you test that, or?
I don't really feel like I have good ways to test what I said, but I have an inclination that there's phase conjugate waves forwards and backwards in time. And I think that's what the Freemason symbols are really representing, because you can use those symbols and the oval with the focal point to make a line, and you can travel along that line this way or this way. And when they meet, just like the Bethe-Hilter process of equal waves combining, that's just like north and north of the magnets coming together of the ether flow.
Right.
And that creates the toroidal moment of a ring coming out, just like how you were talking about the two wires and that charge density and how they want to push out. Well, that's creating a toroidal moment that's pushing it out of that flux density.
And the other one Dollard showed, this lecture he did, oh God, it must have been well over 20 years ago. He was talking about in the old days how they were able to switch the high voltage lines on and off from the substation. So they would have those two poles. Actually, I have exactly that, like a couple kilometers away where I live. If they wanted to disconnect, right, and break the connection from the substation, they use these two giant poles, and they just basically spread apart. Problem is, you have a huge influx of power. When this happens, you'll get a ginormous friggin' lightning bolt come off it, right? But what happens is all the transformers at the substation a kilometer away are going to blow up. So they had these massive fires would happen every time they try to disconnect from the power grid. And it's churning out that the amount of energy that is flowing back through the wire back to the substation far exceeds the voltage potential that it's actually generating on the grid. So he's saying, where is this power coming from, folks? It's coming from the ether. There's only one place it could come through. So that one there is a little controversial, what he was talking about, but it makes almost total sense. You would think it'd be, what do you call the, what's the terminology I'm looking for? The when you separate, you get the differential. It's a sudden drop in potential. So any power that's in that line to the substation now comes as a flyback.
your drift velocity gets reset, and it alters your phase alignment, so you get a bunch of destructive interference sometimes. So really all they needed to figure out was how to phase align everything, just like how they figured out how to phase align their crystal radios, like when they
Right.
do the 45-degree cut on the dual point crystal of the quartz, and how that creates a refraction pattern of rings of light, like the rainbow.
Yeah.
They just needed to figure the phase alignment out like that. And
Yeah.
then they would be able to harness that, like the triode amplifier, like Tom Jordan was saying.
Mm-hmm. Well, I'll get back to that in a sec. So I actually have those type of high power lines not too far from where I am, but which is
Where do
kind of
you?
weird. There's actually a substation right there where those separation wires happen, like the two booms, and I believe there's 4 of them. So maybe they do one at a time in sequence, and that might drop the potential down. I would love to see those things get disconnected. I would love to be there if they ever had to do that.
Where the orbs are hunting you all the time?
What's that?
The orbs? When you see
Oh,
are
the
in the
orbs?
orbs? Yeah.
You know what? It's funny you mentioned that. I would be very interested to see if there were any orbs present when that was going on. I would put money on it that they would be present for that event.
Yeah.
Yeah.
Does it create a vacuum in time when the field is arching in space without the
If the
the
energy
lines?
density is big enough, sure it would.
I mean, like that
If
gap, there's a gap in time there, right? Because if the
Yeah.
electricity is passing that way, and
yeah,
then but you disconnect it right there, and then you get an arc, what happens to that part? And
Yeah.
it's
how
well, that area is getting ionized for one, so you're going to get a huge amount of ozone in that space. So the air in that area, I probably wouldn't want to be around it. It would probably be incredibly ionized. You're probably able to smell it. Yeah, it's one of those things that a lot of people haven't really done much research into, and
Wow.
even Dollard said himself, when they were blowing up these substations because of the switching mechanism, you had GE and then you had Westinghouse pointing the finger at each other. Oh, your device sucks, and the other guy would say the same thing to their, because even GE and Westinghouse they weren't able to solve that problem, and they blew up quite a few substations, and they were violent, very violent explosions. Like we're talking several million volts, right?
I mean, the theory comes to my mind. It's like it creates it creates a magnetic flux, but there's also within it. It has like a vacuum into the center, of that. So
The
it's
dipole.
But yeah, you have a
yeah,
force. If you have a magnetic flux, you're gonna have a force, so it's gonna drain you in one direction or the other.
yeah, and time would have a like it would be like a gravity well, and time would dilate in that moment.
Yeah, exactly.
Yes. Guys,
Yeah.
Talking about time
my
dilation,
experiments confirm.
Well,
did you?
I think I told you guys this story a while ago. There was naval shipping yards out, I believe, uh, on the west coast. I forget what state it was in, but they were building the battleships back in the First World War, and the Second World War, and they needed a method of welding the armor plating of the battleships together. So what they came up with this novel idea of adding flux in between the two plates, and right next door they would have this giant warehouse with massive capacitors. So they would fill up all these capacitors up with this huge amount of potential and basically shock the two plates together. So what was happening as a result of this explosion of electricity, the guys, they would tell the guys, you got to clear the area. We're going to do a blast. And they would forget maybe a wrench or a screwdriver, and leave that in that area. Well, after they do the blast, all those tools disappeared. They weren't there anymore. So the tool handlers start accusing the workers of stealing the tools. And they go, no, we left it here right in our workstation. But after you guys did the blast, they disappeared. So they put cameras down. They did the next blast on the next set of plates. And, they put some tools on pedestals. And they had a camera with them at a distance so it wouldn't get any interference. And sure enough, after they do the blast, all these tools disappeared. Right after that, that whole thing went into a black project. And I think that was kind of a start towards the Philadelphia experiment. So
Right. That's like John Hutchison.
This is too
the
cool.
Hutchison effect, yeah. So that's a true story. And apparently it did go black and they stopped doing it and they did it the old-fashioned way of just welding everything. Took a lot longer to do, but they didn't want this information to get out that if you use a high enough voltage and shock two metal plates together, things disappear.
Mm-hmm.
They didn't want that to get out, right? So
it would be interesting to do like the x-rays and the scans and the tomographies at the same time, because if it's oscillating and it's disappearing in some field and you're measuring on different spectrums to see which spectrum it falls on, it's got to exist in one of these.
See, the problem is back in those days, Lulu, you're talking 1900, 1910, 1920. They didn't have the camera technology to take pictures to see exactly what was going on. They didn't have high-speed cameras to really capture. It's not like what we have today, right? So they were limited on observing with a device, right? So they just knew that there was something really creepy going on, and they have to explore this because things disappearing, that definitely churns a few heads and says, what's going on? We gotta investigate this. So
yeah, but keep in mind, Elia, that I don't think quantum mechanics is probabilistic. I think it can be predictable 100%, and we can harness it to its full extent. That's my perception.
I think you're right. There's just so much noise around us that it only seems uncertain from our perspective.
Yeah,
and
exactly.
As those plates are being driven together, you're basically increasing the frequency of that light until they touch, which is basically as close as you can get. And you alluded to X-rays, right, which is very high frequency light. And then it goes to gamma rays. So you're starting to touch the atom, and then you touch the nucleus. And then basically there's that hysteresis of those other wavelengths of light too, right? Because it's like this broadband sweep, right? You're going from like radio to like microwave to like your X-ray into your gamma. And so you're almost going through the entire orbital structure into the nucleus. And then once it touches, the phonon and the photon are converging, and weird things happen.
Yeah. Well, you're getting most of the hysteresis at a lower frequency band than you would a higher. Like it still happens at a higher frequency, but a more noticeable hysteresis, obviously, like 60 hertz, right? You touch 60 hertz, you're going to burn, right? There's there's heat there. That's why most of my systems, I try to run it well over 200 hertz. And that's why most of my energy is cold. I have very little hysteresis going on. So there's Bernie.
Hey, Bernie made it alive.
I did. I was stuck in -20 on the side of the highway because I decided to push my car that I don't know the tank amount of gas. It doesn't have a gas light. We made it. We made it.
You follow my advice that you do not poke the bear.
No bears were poking. Didn't poke no bears. Survived Banff. It was wonderful. I'm sad I missed Eliza's presentation. I caught like 2 minutes of it before my phone died. That was also fun, having my phone die while out of gas on the side of the highway in -20 in a blizzard. But hey, where's the line?
You're lying.
So I'm gonna have to rewatch this. We got to do this all over again.
Yeah. Well, we got about another 15 minutes. Yeah, we can just kind of go over a few things what Elijah was talking about tonight. So I guess I'll leave it up to you, Elijah, if you want to touch base on something that really interests you.
Yeah, one more thing I want to touch base on is if you have plug flow of water, essentially, that
Right.
plug flow of water will make real voltage because the hydroxide and the protium will aggregate in the presence of the magnetic field, Earth's magnetic field and whatnot. And especially if you do it on a plastic, because the hydroxide wants to grab onto that plastic. And you can create hundreds of volts with that plug flow just from water, and you can light neon bulbs. And also, the water has the hydrogen component, which has the UV band at n equals 2, and then the passion line harmonic at n equals 3. So we can utilize the heat of an engine, and as well as the thermal gradient across, let's say, an aluminum cylinder, to create the Seebeck effect, to add some extra electrons if you want. And then you can use basically that aluminum cylinder as a UV laser to break apart that water. You can make that water mist out, and you impulse it with DC, and that impulse of DC is basically your little spark gap, right? Which is your broadband amplifier. And then that mist goes to steam, and then the steam goes to actual dissociation of the water chemically. And instead of being like 0.33 COP, you can make it like 3 COP or more. And that's just something I wanted to bring up, because they always say, oh, you can't make more power out of water than you can put in. But that plug flow example is like a great example of more power out than you ever put in. It's just a matter of making the infrastructure cheap and scalable for people.
Okay, I got one for you. I was listening to an interview on Danny Jones a couple of weeks ago. He had a Russian-American physicist on his show. He's in Florida. He's actually building a fusion reactor in his house. But he built his apparatus, and he was using mineral oil to keep the reactor cool. So he had a pump filtration system to filter the pump with Teflon tube, and he had mineral oil going through the Teflon tube. Well, guess what started to happen? He started to get electrical arcs coming off the tubes and hitting the apparatus. The mineral oil going through the Teflon tube was working like a Wimhurst machine or a Van de Graaff generator. It was creating thousands of volts, like 2-3 inch sparks coming off the Teflon tube, just with mineral oil going through the tubes. So he made a circulation pump that go through the reactor, through the pump, around and back through again. As it was doing that, it was creating electrical arcs on the side of his apparatus. So it was creating.
Was it circulating on the horizontal plane? Because if so, it's going to also use the Hall effect to its advantage with Earth's magnetic field.
It could be. He didn't really get into much detail on the setup, but the fact, mineral oil going through these Teflon tubes was creating basically like a liquid type Wimhurst machine. Huge voltage coming off it.
Wow.
Yeah. So,
do you think it was like plug flow type flow, like with hitting these bends, or what do you think was happening?
No, it's the circulation going through the pump system going through the Teflon, and Teflon's one of the best dielectrics. So
Right.
the particles, so the minerals that are in the mineral oil are rubbing against that Teflon tube as it's being circulated through the system and creating this charge. So,
Very
you
cool.
kind of, you can compare it to a Van de Graaff generator or
Yeah.
a machine, because the Teflon's interacting as a dielectric, and you got the minerals in the mineral oil making the charge just by pumping it through the tubing in a circle. So that's one experiment I might actually try in the new year. I'm really curious to try that out.
Yeah, go for it. It sounds like a really cool version of the Van de Graaff.
Yeah, just using liquid and pumping, putting it through a pump. Yeah, yeah. There's so many things like you've done such a huge broad uh, 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 study into so many different areas. It's mind blowing. Like, you've really done your homework. I really take my hat off to you for how many years have you been studying this stuff? Must be 10 years.
I've been, that's about right. Like, I started my college studies in 2016, and even outside of school, I'd distract myself with video games and whatnot, but I was just curious and I couldn't help it. Like, it was just an insatiable thing. I was always looking to learn something, and it's just never stopped. And especially since I've stopped college, it's just multiplied because I became the experimentalist, and through that I learned way more than I have in college, because the universe does not lie. And when you make something that reduces your power bill from $120 to $35 a month, and the power company's calling you up, and there's solar companies trying to come to your door and elicit information, and the Treasury Department's calling you up and telling you can't manufacture 0 point energy, and people like John Hutchison and Malcolm Bendall and Alpha Prospects are seeing me. Just being seen feels like such an encouragement, where it's lighting this fire inside of me, where this feels like a drop in the bucket. I want to change the world.
Well, the thing is, I think now, a lot of things have happened in our world, and this stuff is being given a second look, an honest look by real academics. Now, the academia has kind of been like this, closed loop box. They have all these laws of whatever. They made all these laws. You're not allowed to pass the laws, otherwise you're pseudoscience. You know what I mean? When I look at academia, I'm thinking to myself, you know what? Okay, yeah, these guys have learned legitimate stuff, but you know what? You don't know everything. And they make it sound like they know everything, when in actual reality, they know just about that much. Like, we haven't even broken the barrier yet. Like, we're not even there yet. You know what I mean? Like, I think they're putting themselves too much on a pedestal. You know what I mean?
Yeah. I think in my mailing list, with 40 people in it, 40 PhDs or whatever, there's Jack Sorfati in it. Initially, it was like he was insulting everybody, and
Jack Sorfati.
Jack Sorfati, he was insulting everybody, and I took him down very quickly, and he couldn't explain a very simple thought experiment.
Yeah,
which is
it's the same thing with me when I went on APEC for the first time. They were talking to me, and they said, "Why are you so worried about this free energy thing?" I said, "How do you think you're going to get anti-gravity? You're not going to get anti-gravity until you figure out the free energy, because you're going nowhere."
How are you going to power your devices, guys and gals? Right?
Exactly.
It's started.
Yeah,
I think I figured it out with APEC. I'll let you know after the show.
Yeah, exactly. Like after that, I never got an invite back on, because they didn't know what to say after I said that. I said, "You guys are going nowhere, dude. You're going nowhere fast. You got to figure
Yeah.
out the energy first." And chances are the energy part is going to give you a lot of hints onto the gravity part because they're tied to.
Chances are that APEC is a Mossad operation that is a honey trap. So, there's also that aspect.
That too, yeah.
I still get invited to APEC. I still go attend their meeting. I put
But
it on and then
the
I listen. So
the thing is, I noticed everybody wants to have their little 5 minutes of fame and glory. So Jack Sarfatti fits best for that. He likes to be on camera and and
Pop up
have his
gatekeeper.
glory, his 5 minutes of fame all the time. So that's all it is. They don't want they're not seeking they're not seeking a solution. They just want to have their little
Feed
community.
their egos.
Yeah, exactly.
Yep, exactly. So we're going to square up here in a couple of minutes. Elijah, can you just tell everybody how they can get a hold of you, your YouTube channel? If you want to post it in the live chat, please do. And yeah, check out Elijah's stuff. And yeah, that'd be awesome. Get some more traffic. And
Yeah.
yeah, for sure.
My channel is Elijah Tack, ELIJATTACK, and I got lots of playlists and lots of videos I made in a pretty short time span. Kind of taking a break right now on making videos, but I want to do more water research as well as elemental transmutation in the future. You can go on my channel and my email is there, and you can even email me if you want. You can find me on Facebook with my name, Elijah Coakley. Feel free to follow me, and if you direct message me, I'll even add you as a friend if you want, and we can collaborate. Just last night I was collaborating with someone through direct messaging who makes HHO for vehicles, and he's
really?
working on basically he has 700 watt input and 8 kilowatt output, and I told him some ideas of how to get his input trigger down on the input side, and so that is something I'd like to do in the future as well. And I want to even make art out of water that is interactable so that it's undeniable from a principal perspective, and put it in a museum or something. And then maybe from there, once that's all established, I can make the water fuel injector, because if they try to kill me then it's kind of like the information's already out there,
You'll be a martyr.
I feel you on that, Elijah. We are going to collaborate on that because, developed that a lot. It's like that same little fear of.
Well, all I have to say is, Elijah, you have so much.
We're just trying to make the world a better place.
So
I just
sometimes
wanna
I wish. Sometimes I wish that the Men in Black would be after me because I'm bored,
You might think that, but when you trigger those events, speaking from experience, it's not very fun. You have to run, and it's not good because they got the helicopters and they have the SUVs, and you need a hell of a head start. So, just
I'm I'm 1,000,000,000% sure that all my digital data is going to a call center that's run by the government. They answer my anything, any digital correspondence, and they try to sabotage things, but I catch the glitches in time for them. I'll tell you, if you guys want to hear it after the show, or I could tell.
Elijah, you could after we go
But
on, just stay
glitches in
on.
time.
Don't leave. Stay in the backstage after we sign off. I just like to say I love to have you on again because you got so much knowledge and some new fresh content for us. So definitely next Friday, if you're up to it, you can join our live stream again. You got an open door with us, And
Cool.
yeah, I'd like to hear more from you. So we go live here again next week. I know Christmas is coming up here. So I think there's 2 weeks to Christmas. So I guess
you cannot say Christmas. You need to say holidays, or you're gonna otherwise you're gonna hurt people's feelings.
Xmas.
here we go
Oh
again.
my God! You can't use
I'm just
Christianity.
kidding,
Happy
man.
holidays. It's a lot
I'm
of
just kidding,
holidays.
man. The
No,
opposite
I'm
of
gonna
what we
say
need to
Merry
do.
Christmas, and that's it. If they have a problem with it, they can call me. I'm not gonna fall for that crap.
Christmas is
I
not
mean,
canceled. Okay.
New Year's is a holiday. You know, some people enjoy New Year's much more than other holidays.
Hey, now
No,
you're
but I mean,
offending the Orthodox and the Chinese, all right? Because their New Year's different. So yeah, you're canceled now too, Lulu. Shit.
Oh my god. Anyways, guys, have
Sorry.
a great week. We'll see everybody next Friday, and don't forget to give the show a thumbs up, and also visit Bernie. And also, if you haven't become a member of the Faraday Research YouTube channel, you can do so. Help support our channel and all these great guests that come on. And thanks to our panel, and we'll see everybody next week.
cheers.
Bye,
Cheers. Take care, everybody.
What's up?